Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning. I'm Gopal. I'm from Music Technology Group, which is located in Barcelona. I'm a third-year PhD student in that group. In this talk, I would like to go through the work that is going through in the department and also within the project. And at the end of the talk, like in the last part of the talk, I will go into a little bit of detail into my thesis. So I don't know how many of you are familiar with this domain, music information research. It's a domain which deals with information extraction from music data. Music data doesn't essentially mean just the audio data, but also the metadata associated with it and all the web data, which are social networks, the discussion forums, Wikipedia information, any literary stuff, anything. So having to deal with many of these diverse modalities, it's inherently an interdisciplinary domain. So these are the most frequently seen domains in the conferences, and of course the machine learning, signal processing dominate pretty much everything else. And there is a problem with this. I mean, not with the machine learning and signal processing, but the way they are used exclusively without much interpretation. These are the tasks that feature in MIREX, which is Music Information Retrieval Evaluation Exchange. It's like TREC, which is run every year with a conference where people submit their systems for evaluation. And so this pretty much should give you what kind of information extraction tasks that are usually seen in this domain. And so as I said, there are some problems with the current state of this domain, which is like in the first case, the information models that are being used for past 15 years, they haven't pretty much changed. They have remained the same, and which is to say that whatever started in Western popular music, which is at that point of time and even now driving the markets, the schemas and the information models, everything is modeled after that music, and it stayed the same. And now when people are starting to process other kinds of music, they are not enough, and people unfortunately are forcing those schemas on new musics. And some use too broad a concept to describe something very specific. And even in the case of methodologies, as I said, because of this using signal processing to extract some features and then run it through a machine learning model to learn some features that will help in doing some task like genre classification. So, but we don't essentially know what exactly constitutes a genre, for example. So we are not in a position to define or tell what features or what properties of the music result in saying demarking it as a genre or a particular music or anything.
So what kind of features do you actually use for?
That depends on the task. For genre classification, it's MFCCs and others, timbral, spectral features. And also, if you remember the first slide, it shows you 3-4 data modalities. But to be frank, most of the approaches which use each of these data modality, they are pretty much independent, and they don't essentially use one data modality to reinforce the information from other one. So these are some of the problems with the current state of this domain. For example, an example is as fundamental as this melodic framework, even this concept has a very big schema problem. So usually the papers or the literature which were existing till now, they talk about scales. And when it comes to melodic frameworks of other musics, like Turkish Makam music or Indian classical music, they are very differently formulated and they need a different information schema and a different way of approaches. So scales are basically a set of notes and which are fixed frequency points and well defined. Ragas, on the other hand, depend on a different formulation. Swara, which is a frequency region owing to the melodic movements. Maybe I can describe it later. And in scales, ornaments, which are glissandos, all the vibratos, everything is not inclusive in the scale. But in the case of ragas and even in the case of makam music, for example, they are inclusive. They are not ornaments as such, they are included within the definition of raga. And quantification schemes are different. So this is where our project comes into existence. So maybe I can tell briefly about my project before it gets on. So when my prof visited IIT Mumbai 3.5 years back, he was presenting all these state-of-the-art approaches for music information research for the audience there. And one of the things he noticed is that most of the concepts used in Western classical and Western popular music, they are not very, the audience here are not very well accustomed. For example, harmony, chords, and everything else. Even the concept of genre is pretty new here. So it's not very well defined as such. So going back, he applied for this project called Comp Music, which is to say that these different musics need different approaches that are based on their own cultural context and which take into account all these differences. Well, so that's where the Comp Music project started, and right now just a second. This project includes all these countries, mainly India, China, Turkey, Morocco, and Spain, southern part of Spain. So this is the team, which is now 50 strong. This is 2 years ago. And here in India, we collaborate with IIT Madras for Carnatic music and IIT Mumbai for Hindustani music. And we have collaboration with musicologists and musicians to help us validate our approaches. So these are the different music genres or styles that are identified across the globe for this project. The key point is that each of these culture is still in practice, and they have a musicological literature, thorough musicological literature, and they are in practice. So you might have heard Hindustani and Carnatic, so I did not include any audio samples there. Sorry, but maybe we can listen to these sounds to give a sense of what. This music, it started from southern part of Spain, Andalusia, when Muslims ruled Spain. And then when they were kicked out, it moved to Morocco, Algeria, and other parts. And the compositions are not new. They are all old, and nobody composes anything right now. But it's it's practiced in weddings and other ritual stuff. So whatever is there, whatever we can get, we got everything. So we have 100% of the collection of this music.
How big is the 100%?
So the compositions, the number of compositions are 65, I guess, and each span a day, and they are divided into sections, and they are sung by different people. And whatever we got, they are not recorded by any label. It's recorded by a musicologist, and he privately shared it with us. So there is no recording culture in this music. Nobody records this. And this is Beijing opera. There are different kinds of operas in China. The reason we selected this is because we can reach out to Beijing easily, and there is a musicologist from Spain who went there and learned the language and everything, and we can easily collaborate. But this is quite representative of the region in general. The former music, it's a kind of heterophonic where they follow a single melody but each have their own embellishments and all. But in this music you can see it's a polyphonic version. I mean the lead singer sings something but the instruments play something else. And there is a strong percussive strokes by melodic instruments, and which make things very complicated. And this is Makam music. So in that music as well, it's kind of heterophonic, but there is a different melody line. There are subtle differences, but it's a different melody line.
So in Andalusian music, which sounded pretty much like Turkish to me, do they have quarter notes like Turkish as well or no?
I'm not sure. We just started work on this.
Doesn't sound like.
Yeah. But we just started work on this. Nobody is working on things yet. We are still collecting the data. I think we'll come to know soon. So this is a broad picture of what we are doing in the project with all these music repertoires. We start with data gathering, which involves all this curation of, selective curation of audio from consulting musicologists and musicians, and putting up everything on Music Brains, which is a repertoire where all the music metadata is shared publicly. And then, we consult musicians and musicologists to figure out what in each of these tasks, what should we do in each of these tasks. So just to give a brief overview of the data we have, this is some time ago. These are not up-to-date figures, but right now we have plus 50 something. So this will be around 300 CDs, that will be around 280 CDs, and so on. So this is the smallest of all. As I said, it's a privately recorded collection. And once we have the audio, we extracted all the audio features and made them publicly available through an API. And if it's for a research purpose, I think the audio is also available. And all the editorial metadata, as I said, is on Music Brains. And we also collect and crawl all these sources of text data. And here is where we shared all the data sets and everything. And yeah, so after consulting the musicologists, we figured out some of these tasks, and maybe I will present some of them, not everything. For Indian classical music, the most fundamental task in music information research is tonic identification. The tonic is something which you hear in the background of a classical concert in India. It's played by the drone, and usually it has the lower pa, the middle sa, sarigama padanisa are the swaras, which are notes analogous to notes, and the lower pa is the lower fifth, and sa the tonic, and upper pa. So these are the notes that are played by the drone. And this is from the spectrogram, and you can see that these lines, the study lines, they represent the drone. And there are 3 or 4 different approaches that are in vogue now, and it's pretty much, we believe that it's a pretty much solved problem as long as there is a background tampura. And also, these are not strictly machine learning based approaches, because we know the rules, why it works, and we know why it doesn't. So the way they did it is that they have a purely data based approach, and there is a rule based approach, and then they correlated whatever is working and whatever is not working, and they have some understanding of why this data based approach fails in some instances. And the next fundamental problem is intonation description. So a raga is a collection of swaras, and each swara has its own melodic context. So let's say there are 5 swaras in a raga, and the second swara S2, let's say, is nearer to S1. Since it's nearer, the movement which is played or sung of swara, it's restricted on the left part of the left spectrum of the frequencies, and it starts maybe on this second swara and moves more towards the right. If it's restricted on the both sides, then it's pretty much sung at a constant frequency. So based on the melodic context or their positions in the frequency spectrum, they are either shaken too much or sung with different contexts. So basically, each swara, a given swara in different ragas, will have different contexts. Based on that, we say that it's intoned in a different manner. So that's what intonation means, and we are developing some methods to capture that information. And this is what the first part of my PhD will be, and I will be talking about a couple of methods for that. The next goal is to extract the melodic patterns. So in a raga is strictly not a scale and strictly not a melody, a fixed melody. It's defined to be somewhere in between. So there are some fixed phrases which give a feel of that raga. They arise because of these restrictions on the swaras. So there are some movements which have to be sung in a particular way. There is no other way you can sing them, and they are very characteristic to the raga. And now, so finding them, and so imagine a raga sphere, a raga space, and you want to say which raga is similar to which other raga. And one way to do that is the intonation description, where you say these swaras in these 2 ragas have similar intonation, so they are similar. And the other way to do is saying that these motifs are present in both ragas and hence they are similar. And that's all melodic analysis, those 3 things. And then we have this rhythmic analysis. The work on this started last year. There is not much yet. Ajay, who spoke a couple of years here before here, and he is now working on that. I hope this is working.
You worked on source separation.
Identifying the pattern.
Yeah. So the goal is that there are these red lines and there are these green or blue or gray lines, and so this is the downbeat, and these are accented beats in the tala. So this whole thing comes as a tala, and as you can see, the stroke doesn't necessarily say that. I mean, there is no obvious way of from the strokes alone, there is no obvious way of saying it. So there is a stroke here as well. So yeah, the goal is to track tala, which is to track the downbeats, the accents, and the pulse. Indian music doesn't have a score as such. It has some notation which is limited to lyrics and the swaras which are sung at that point, but not so much the movements and everything else. So this is specifically this core to audio alignment is specifically being done for Makam music of Turkey, which has, even though it has this many movements, they are not as well defined and formalized as in Indian music. And people still are okay with hard coding the music and then keeping it in a notation form. So that happened mainly because of political reasons, but today they have scores for most of their compositions. And so here the alignment that currently we are working on is at section level and also at note level. And we are using some part of this to partly align phrases in Carnatic music, which I will talk about in the second part. And another interesting aspect is that the lyrics and music in Chinese music, Beijing opera. because Chinese is a tonal language, the same word can mean many things when you intone it in a different manner. So for example here ma, based on how you say it, it can mean a mom or a horse. So, and when people compose lyrics in this language for their music, it interacts with the music flow, and it creates an interesting interplay. So one of the hypotheses, our hypothesis, is that they try to sing the lyrics in a tone that they learn from language, and so it's still being tested. And the next part is designing ontologies and learning, automatically learning and populating the ontologies. So we have developed some top level and some concept specific ontologies for Indian music to start with. We already have raga ontology and top level ontologies for Carnatic and Hindustani. By top level I mean ontologies encapsulating all the main concepts in that music. For example, performers, composers, ragas, talas, everything else. And in terms of studying communities, we started analyzing some data from discussion forums, and the only discussion forum till date we found is of Carnatic music, which has a very strong community that maintains this discussion forum, and it's quite active. It's called rasikas.org, and we have done some analysis which gave us some insights into who is a guru of whom, and who sings what, and maybe like the associations between the kind of instruments in the concerts. And so yeah, these are the main ensemble of a Carnatic music, and the associations between a composer and the talas, composer and a raga. So what raga he composes frequently in, these kinds of details. And at the end, our goal is to integrate everything into a system that allows for exploration and navigation of these music repertoires. And we already have a prototype of that, and maybe at the end I will give a demonstration of this prototype. It's called Dunia, and it's the idea is that we have all the concepts here, and if you can filter out these concepts by selecting multiple versions of them and querying them, and you will be shown different kinds of results that match this query. And once you go to the recording page, that's where all our work comes into play. So you can navigate the recordings, navigate the albums, artists by the analysis which we do. So as I said, similar ragas by intonation description, or similar ragas by motivic analysis, so on and so forth. So that's the first part of the talk. That's the broad view of the work, the kind of work being done in the project. And in the second part, I'll talk about some details in my thesis, which is to develop similarity measures from all this information. And I will be mainly working on these two information extraction tasks. One is intonation analysis, and the other one is ontology learning. So one comes with this part, and the other comes with this part. And finally, when I have some similarity measures built on top of this multimodal knowledge base, then we integrate that to the system. So maybe to quickly understand what this thesis is about, I gave an example of the result, the kind of result I want to see at the end. So till now the system say, okay, something is similar to something else, but in this thesis we want to say it is similar by a quantity and a similar because of some reason. So we want to juxtapose the modalities. So this comes from the audio description, and this comes from the information extraction part, and we want to establish these correlations and associations between these two modalities, and similarly between other entities. These are ragas and these are artists. So this is an overview of the thesis. These are the data sources, mainly the unstructured text which comes from the web, Wikipedia and other sources, metadata which we have curated on MusicBrainz, and audio notation files. And this part is where I deal with information extraction, mainly ontology learning. The idea is to use this new information extraction paradigm, which is OpenIE, that intends to scale to the web. And from here I'll have an ontology and a knowledge base. And from audio analysis, this is the only part that is part of my thesis. These which are indicated as predefined processes, those are not part of my thesis, but I'll be using them. And here I'll have some descriptions for some relations between artists and ragas in a quantitative manner. And at the end, we will merge them to multimodal knowledge base and compute some relatedness measures or similarity measures. So the fundamental hypothesis of this thesis and the project as well is that music cultures differ. And there is a lot of discourse that music is a universal language, and so these concepts can be generalized, and to what extent can we generalize, and so on. So we try to validate our hypothesis, saying that we need different kinds of approaches because they have different concepts and the formulation is different, and the structuring of the music and the way they listen to everything is different. So by musical characteristics we mean these things. I mean anything that comes under the lingo of music. And the salience, by salience we mean how important is that particular characteristic. Say raga, how important it is for jazz music, how important it is for Indian music. And an example is if you take dance, it forms a very core element of flamenco, and it coexists with it and defines flamenco. Whereas in Carnatic and Hindustani, they help other dance forms, but dance is not an integral part of them. And with Baroque and jazz, they are not associated at all. So this is the process for validating our hypothesis. We started with wiki pages. I'll explain the reason why wiki pages. So we stripped all the structured content from the wiki pages and kept only the text part. And then we linked the entities. That the title of the page is the given entity, and the links will be the references in the page. And then we did a page rank and got the most relevant, the most important entities in that music. And then what we did is to find the characteristics of each of that entity. So for example, here there is a page for T.M. Krishna. He's an artist and he will be associated with some of the Wikipedia categories. He's a performer, he is a Tamilian, he is born in some village, and so on and so forth. So these are all the characteristics of that entity, T.M. Krishna. And we used T.M. Krishna's rank here to compute the relevance of the categories he is associated with. So that's done in this way. So let's say pages or entities is E, and P of E is page rank, and C is the characteristic or the category. And what we did is to take inverse document frequency of the C, so that if T.M. Krishna is both composer and a performer and there are too many performers, then it's likely that he is identified as a performer in a broader way. So, but this resulted in some erroneous results, which like so C Rajagopalachari is associated with Carnatic music, but he is a politician, and he is the only person in the entire graph who is a politician. So, but he has some medium relevance in the whole graph. So all the political categories turned up. So we need to do a pruning by filtering out, saying these categories which occur certain minimum number of times. So this gave us a score for each category.
So you used the entire Wikipedia for this? Or?
Yes. So I think there are around 20,000 pages for jazz, and it comes down to 300 pages for flamenco. So there is a lot of variation, but we used the entire Wikipedia for each of the music cultures. These are the results. Maybe I can read them out. So in Carnatic music, the most salient ones are that its association with the religion and the terminology, which is very important, and the terminology doesn't occur in Baroque or jazz, for example, and flamenco. It occurs only in here and here in Hindustani. And there are ragas, and yeah, in Hindustani you can see these gharanas. Here, the Bihar, Uttar Pradesh, and in jazz, for example, there is this Buddhism and the record labels. Baroque, the saints which contributed to the music and the German area, and so on and so forth. So we have some good result, and on top of this we have to validate if this is really helping in anything. We build semantic distance, salience aware semantic distance. So what it does is, if two artists, let's say two entities, two musical entities feature in one of the top categories that are identified for one of the salient categories in that music, they are recommended as closer than another two artists who feature together in a low salience category. So this, in fact, we did a pilot survey on this using this and comparing it with a linked database distance, and we found out that this in fact has a very different complementary set of information that is from the structured information which is already present on the web. So yeah, so this pretty much supports our hypothesis and also helps us to build some distance measures on top of this knowledge to enhance or get some different kind of information which is not there in explicitly in the current structured data. So the first task after validating the hypothesis is description of intonation, obtaining it automatically from the recording. So till now this intonation is studied under the name of tuning, and the tuning usually is constrained to studying the location of the notes. But here we don't want to see the location; it's a region. So we have to broaden the approach and include this particular definition in our analysis. To just okay. So this is the usual setup of Carnatic music. I started working on Carnatic music for intonation description, and violinist usually follows very closely the vocalist, and there is a very small lag between them of the order of milliseconds. So usually the monophonic pitch tracking algorithms, they go haywire when switching between them. And to give just a sense of what it sounds like, so she never stays on a particular place. I mean, she keeps moving all the time. So this is what I am talking about. So when you say intonation of maybe this particular swara, it's not just this part but the entire part. So the first approach, well by now I think you know the intonation. So the first approach we followed is this an aggregate approach, just to check if we are able to capture this intonation information somehow, and that's pitch histogram parameterization. By that I mean, so these are two different ragas, and so the peak locations are very similar if you observe, and they look also very similar. The only thing that can differentiate these two is the shape of these peaks. So that's what we did. We restricted the bounds by valley points or a maximum threshold of 50 cents, and computed these different shape parameters apart from position and amplitude. This is the state of the art in raga recognition until then. It was 3 years back, and we included these. And so this is the whole process. So we started with the audio, and then took out all the vocal segments, and then extracted the pitch for them, and using the tonic we normalized the histogram and got the histogram, picked the peaks and characterized these shape parameters. So as I said, there is a slight lag between violin and voice, and this green contour here, it shows the pitch extracted using in algorithm, and this is the blue track is using a predominant melody extraction proposed by Salomon and Gomez. So you can see that this is the violin part, and this is the vocal part. It keeps switching between them. The violin is usually tuned a octave higher. And once we have the histogram, we normalize it using the tonic. You can see that this is this is not very smooth. I mean, there are many erroneous peaks that can be extracted from it. And for that, what we did is to introduce two parameters, which is LP and DP. They are depth and locality parameters. We pick a peak if there is a depth of dp on either side of the peak in points at least LP points ahead. So, well, this constrained the number of peaks to mostly the valid peaks which we wanted, but still there are a lot of erroneous peaks. So what we did is we computed an average histogram for the raga, for taking all the recordings of the raga. So this is the average histogram of the raga, and to just juxtapose that with the individual histogram, this is the one. And you can see that there are many erroneous peaks here which can be discarded comparing it to the average histogram. So that's what we did. Our goal is not raga recognition yet. All we wanted to check is that these new parameters somehow capture extra information which is not there in position and amplitude. So the way we checked it is raga recognition task. There are two other tasks which I did not include here, and in that this is 3 years ago. At that time we did not have a bigger data set, so I tried it on 3 ragas, 42 recordings, and I noticed that there is a good improvement. I mean, it's not statistically significant because these numbers are too low, but there is a steady improvement using any classifier.
So how similar were these ragas? What ragas you showed?
I don't exactly remember it. I can refer to that, but it's
So
long.
ragas will have different scales, so
Yes,
they'll be
yes,
very easy to identify.
yes, yes.
So they have
I think since we are we are comparing against position and amplitude, I think I chose both. Like there are 2 ragas which are allied, and there is another raga which is not allied to these 2 ragas. And so the next approach builds on top of this, and the kind of the problems which it addresses is, the first one is this steady swara which are quick transition. So both these renditions, they can be sung with the same swaras but in different ragas. So this can be same as this when they pronounce it, but so as we see this is completely different, and we need to have a method that can capture this information, whether the swara is steady or whether it is moving up, down. And another problem is that we are restricting the peak to a strict bound. Here, if I draw a line and say this is the end of the peak, that's not true exactly. So the pitches of this swara, they span all the way here, and when they sing this swara, it goes all the way here. So there should be some way to segregate these peaks in a intelligent manner. So what we did is, this is the contour. We started looking at a particular segment, and we have a window starting at one end of the segment, and we moved the window till the other end, and we computed the means of the window. So it gave us whether these means are rising or falling, or they are pretty much steady. So we have an information of whether this particular swara, this particular segment, and the swara which it is sung in, where exactly it belongs in the whole pitch histogram. So we finally have this kind of output, where we say that the pitches here, they go to this swara, the pitches here, they are sung for this swara, and so on and so forth. So we have some way of saying which pitches in the melodic contour are sung for which swara. And this we tried on more recordings. The result here, the task here is of on 6 ragas with 69 recordings, and it is compared against the previous approach, and the difference is pretty big. And we also validated this result with the musicians, and there are many discrepancies, and they said that okay, your algorithm captures some information of the swaras, but what it captures is wrong, but it's capturing in a very consistent way across the recordings. So what we had to do is to have a ground truth to test this claim.
So this is again again raga classification.
Yes.
But you are also marking swaras.
Yes.
And you are not.
We are peak picking. So initially we know the kind of swaras it's in, and so in the first approach we are peak picking, so we know the swaras. In the second approach, we just do, so we just have these lines where the pitches belong to.
Yeah, so did you check this one with experts, like whether they will call this as swaras?
No, this they won't.
That's what we found. There is tremendous disagreement.
Yes, they will not.
Where the swara starts and where it
Right.
Something similar, right? So
Yeah, they will not. So what we did is to have a ground truth. So we started collecting some varnams, which in Carnatic music are pretty much sung to the notation, and we semi-automatically aligned it to the recordings which we have recorded privately from the singers. And yeah, the possible improvements in this step are that we have more accurate pitch class assignment and more accurate estimate of the melodic context. So these are the kinds of plots which we got after this task. So they agree with this. So this is the same swara in 4 ragas. So the kind of pitches they sing in these different ragas is same. So this is what I was mentioning in the beginning. If the swara is too close to the neighboring swaras, it is pretty much sung on the frequency. And if it has some, so this is the swara that is being sung, and it is being extended all the way here. So all the way up to 400 semitones. So that's the movement. And here they are singing this swara, and they have both the swaras on both ends, and yeah. So, sorry. So we have T.M. Krishna and his student Vignesh Ishwar, and in Hindustani we have Suvarnalata Rao ma'am in NCPA, and a student of Ajay Chakraborty, Kaustubh Ganguly.
So in this case, 1200 cents is 1 octave, is it? Or
Yes.
Okay. So 100 will be like 1 note.
Yes.
So going 700 is
Right.
going half the scale from
Right.
sa to pa.
Right.
But still they call it the same note.
Right.
Interesting.
So yeah, the movement on that note spans it. I mean, it's not that they call this note as that, but the movement on this note spans till that.
Pretty high on the note. So
Yeah.
And this is a big difference between Hindustani and Carnatic. So Hindustani, you never touch the other note.
Right,
so
right.
the oscillations of
Right. So yeah, that's where we are on intonation description. So we are now trying to automatically align phrase with a notation, and then somehow get the swara boundaries. So once we get that, then I think it's a pretty straightforward thing from here to relate artists and ragas. So a hypothesis of ours, the second hypothesis in intonation description is that it's also characteristic of artists and the schools, gharanas. So yeah, we did not yet test that, but once we are done with this, I think that will be more interesting. And so this work quantifies the relations between artists and ragas. And now we want to say why there is a particular relation, and why is there a particular number on that relation, using some description, human readable description. So these are the broad tasks in ontology learning that we are working on. Entity identification. So entities are all the instances of in the music, all the artists by individuals, all the raga individuals, and everything, the individual elements of all the concepts. And the concepts are these different classes or the categories. And semantic relations are the artist sings songs. So sings is a semantic relation. So these are the kinds of information we want from this unstructured text. So to validate whatever we do here, we need some ontologies, some manually engineered ontologies with the help of musicians and their reviews of whatever we generate. And also we are comparing against, all the already structured information that is available on the web, all the DBpedia and other community generated linked data. So this is a top level ontology for Carnatic music, and this is currently being validated by Sir N. Ramanathan, he is a musicologist, and T.M. Krishna. So this is not still agreed upon, so I might be wrong. So yeah, the way we are approaching it is that we want these ontologies for navigation and not to be as a domain ontology. We may not be the experts, but so our fundamental unit in the navigation is a concert. So we modeled everything after that. So a concert has a performer, it has a venue, it is performed in this concert, and so on and so forth.
I'm not clear on how the intonation is going to help in this.
Yes, so when you relate ragas, for example, let's say I relate Mukhari and Bhairavi, and so there is some similarity. But this doesn't explain, the intonation description doesn't give me a description like why are they similar. It can at best say that this number of swaras have similar context in both the ragas, but it won't tell me beyond that. So they are allied ragas. That's why they are similar. So I extract that knowledge from the text. So at the end, when I recommend Bhairavi for Mukhari, I would also be able to say that they are this much similar, but they are also similar because of this reason.
So you can extract out the notes in both the...
Yes, yes.
And can you also identify, say, R or no?
Yes.
That can be...
Yeah. And this is a concept level ontology. By concept, I can go down to swara or stop at raga. So an example is a swara where it has 7 swaras, and each swara has again its variants, and they have their properties, and they have properties shared with different.
No, sorry, just to go back to the first, the previous one. So the top level in ontology you're just getting from whatever metadata, data from the web, etc.
Well, this is not exactly from the metadata, but the metadata is modeled after the ontology.
But this is the ontology that you have like sat with experts and decided.
Yes.
That's what.
So yeah, we have. I mean, for each of the concepts in the top level ontology, there exists already an ontology which further describes that concept, or we are developing the ontology. And our approach to extract information is basically to use existing open information extraction paradigm. So it differs from the traditional information extraction in the sense that it scales to the web and it does not use the vocabulary of the domain. It's unsupervised. That's what we want because we are dealing with different music cultures and they have different terminology, and we can't adapt the system to every model manually. So we picked up open information extraction as the paradigm, and the main challenges here are examples of open information extraction include this never-ending learning from CMU and know-it-all from Washington University. So the main problem with them is that their recall is very low, very, very low, like I don't know, 10% or something, and the precision is pretty high. They depend on redundancy in the web. But in this context, we can't afford to do that since there is not much data available for each of these music cultures. So we are trying to improve the recall and also identify the domain-specific and culture-specific information that we need to that is being missed out. So one example of this domain-specific information is this Arohana and Avarohana. So these are usually lists, or they have different grammar of presenting them. So this is not this is usually considered as a spam in a sentence, and they are usually excluded from the information extraction systems. But we want to modify the grammars of existing systems and see if we can get them also. And yeah, these are the systems which we have, which we started benchmarking, and we already have a system to benchmark them. We use 2 different kinds of benchmarks. One is based on the volume of extractions they give us given some data, and also the quality of these assertions or extractions. So the 3 systems are the first one, it's purely based on dependency parsing, and the second one on shallow semantic parsing or semantic role labeling, and the third one, it's not exactly an open information extraction system, but it's a deep semantic parsing system which we modified to give us some triples which account to 100% representation, logical representation of dimensions. And then we used those triples we assumed those triples to be assertions. So we compared all these three systems on volume and quantity, and there are too many figures, so I just present some of them here, a couple of them. These are qualitative results for relation extraction on Carnatic and Hindustani data. So as you can see, this semantic parsing based system, it has a lot of redundancy in its assertions. Because of that, it has higher number of relations types that it's very confident that they are of the domain. And and OpenIE, it comes close second, and the reverb, it's the performance of reverb is low on most of the aspects. And so we chose to adapt this deep semantic parsing based system. I am not an expert in NLP domain, so I am collaborating with a couple of researchers in Edinburgh, and so we will change this the grammar behind the system and adapt that particular grammar to whatever domains which we are working with. And the main things that while benchmarking these systems, the challenges we noticed are reification of sentences, like T.M. Krishna said that N. Ramanathan is a good musicologist. So there are two sentences in that set. So this kind of reification is a complex thing, and often these systems miss out on that. And so we can't afford to take that data, let go, because it results in contradictions when we finally put that in ontology. And there are often these sentences in Wikipedia and other discussion forums, which are not strictly scholarly, are very long. They span a paragraph and too complex to get information from. So we are trying to see if there is something which we can do to segment those sentences. And as I said, there is some domain specific information which we want to get across. And this is so we still need to do a lot. The first task which we are done with is intonation description, which we are almost at the end of it. And the second task, which is to label the relations established using intonation description, motivic analysis, and every other audio description task, is still under progress. So we are just done with benchmarking, and now we are moving to actually working on these open information extraction systems. So that's pretty much it.
Okay, thank you. Do you have any questions?
Do you see any, how do you, I'm very naive to this domain, so please expect some not so clever questions. I'm trying to connect it with the music information retrieval, and what intonation detection thing you are doing. Does it help there, or what is the state of the art there, or do you have some idea?
Yeah. Basically, it's the same field. It's getting rebranded as informational research because we are including more data. More different modalities of data. So, for intonation, the previous related work is mostly on tuning. So, detecting or seeing what scale or what frequencies the intervals are tuned to in a particular recording. And there is a lot of work being done on folk music traditions which doesn't have documentation, and they are trying to see what kind of intervals there are in those kinds of music. So most of the work that existed prior to our work in this domain, they are limited to, say, identifying the frequencies in the song, but they did not talk about how these frequencies are sung and their context, nothing else. I think I can safely claim that this is the first work that talks about the context of the interval.
So, related to his question, like, what would be a scenario where a user is querying something where you need both the information, both intonation as well as NLP kind of like metadata and all to answer the query better.
Right.
So,
Yes. Maybe I can start. I don't know if can I connect to the internet? Maybe I can show the demos of the prototype we have that will answer this question.
You cannot, sorry.
Okay. So
you can just tell us one query.
okay. So there is this prototype, and the idea is that we model some user interactions on this interface that will allow this. So let's assume that you are listening to a recording and you would like to say you have seen some phrase which reminded you of some other song, and maybe you can click there, and then the system directs you to different kinds of phrases or different relations based on not just the audio description. The phrase is identified and shown to you by audio description, but the relations that we show further, they can be shown using all the analysis, not just the audio description. So
This assumes a very sophisticated user.
yes. So well, this interface is to test our all our analysis. This is a research prototype. This is not a user product as such, but yeah, we did not yet think about how to take these to users.
Musicians, musical.
Right.
Just also the question, do you see this going further down to music synthesis?
Music synthesis is right now not part of the project, but there are some people working on music synthesis that attended our workshops in Chennai last year, and the main problem is this gamakas and how do they synthesize. Mostly they are working on pitch bending and
your interface can answer questions like give me similar music who has this phrases
Yes.
and is sung by this artist.
Yeah.
Going further, can you also say that given this two music, if I mix them, what is the music? Or sort of those.
That's not our goal, but yeah, it's definitely possible. I mean, music synthesis in Indian music is still a very open problem.
I have one quick question. So in linguistics, we have various kinds of databases. Like one example is World Language Atlas, where you really know all the languages or most of the languages of the world and their all properties. You are trying to do something similar across musical cultures. Is there any such resource?
There is no standard resource on that. No.
Because that would be a very cool thing to do actually,
Right.
and we can talk more about it because
Sure.
this project seems very aligned to that kind of classifying different systems of music using different kinds of features,
Okay.
and then building a map of the world. Like music here has these features,
Okay.
music there has these features.
Well, it's not organized effort, but there are some ad hoc conversations on mailing lists saying, comparing against one music against the other.
But see, you'll have a very systematic description of all these different
Right.
cultural types, right? And then you can actually very easily do this.
Yes. So I initiated something like this on. There is a music ontology. So it's called the music ontology. It's a research thesis of Yves Riemann, and he came up with an ontology for general ontology that can describe workflow processes of music, how it's produced, how it's on media and everything. So when I approached saying that I can modify this ontology for suiting the Indian kind of music, then that's where so these ontologies, they don't exactly put everything in a single place, but when I model an ontology, let's say I say Sabha in Carnatic music, it's a top level concept, but it will also refer to some place similar to that in music ontology, in the music ontology. So in a very decentralized way, these ontologies are doing that to an extent. So they are somehow relating the concepts in both the music cultures. So it's not exactly the same as relation in an ontology, but it's like related concept kind of thing. So there are some links between ontologies which are very decentralized, but they are. This kind of effort is none of.
It's actually the reverse. So here we've not about the similarities, but some distinctions.
Okay, okay.
So, for instance, swara, that no fixed pitch for note, is a very distinctive feature of, say, Makam music, Carnatic and Hindustani,
Right.
but not found in most of the other cultures.
Right, right.
So that's one feature which is turned on for these and not for
Okay,
those.
okay, okay.
And similarly, you can define some, say, 100 or maybe 1,000 features,
Okay.
and that can describe all the world's music.
Okay.
So linguists have done it for languages.
Okay,
It's
okay.
a very ambitious thing. It takes a long time.
Right, right.
It would be very cool.
I was thinking on some other lines. I don't know if you are trying to address the popular music in this domain or not, because mostly everything was cultural or traditional music here. But if you bring in the popular music,
Bollywood.
yeah, Bollywood or maybe the Korean ones or something, some different cultural popular ones, then you have their own local, music, and then there is a phenomenon of music plagiarism, which tries to bring, like Pritam tries
Yeah.
to
Copy.
get some music from there and there. You have some seed lexicon which can try to map from there.
Yes, a shared task in information retrieval to detect plagiarism. So,
But yeah, that can, I don't know, that can give you some related features and try to.
I think there are works doing that, but yeah.
there is no shared task, I believe, on plagiarism detection in music. I haven't seen it.
Music plus, yeah, there,
There's a
yeah,
shared task.
yes,
Okay.
yeah.
In music.
I don't know if it's called by the same name, but this task, yes.
Maybe they call it inspiration detection.
No, there is this. So one of my colleagues, he has done a cover song detection. So they take a song and they build some version of it. So ultimately, this work, it combines all the cover songs and identifies the original version and the associations, which is inspired by what and so on.
Bollywood be slightly tricky, no?
Yeah.
They are very
Maybe
clever.
so many.
It's everywhere, all over the world.
Yes. Yeah.
Okay, any other question? Okay, thanks again.
Thanks.